Alright, what's up everybody? This is Ryan here, and you're watching episode 71 of my live stream Kotlin Android programming Q&A. So thank you for joining me once again. So we'll just get the usual stuff out of the way first. And what's up my friend with the Cyrillic name? I really need to learn how to read Cyrillic so I can actually read your name. But how's it going? Alright, so we'll just get the usual crap out of the way. So, if you would like to support the show, then please do consider following wiseAss on your preferred social media networks. So we have Facebook, Twitter, Instagram, Medium, and we also have a big Slack group where like-minded developers get together to discuss Kotlin, Android, programming concepts, and it's a really great place to get help. I'm generally quite busy, so I often don't have time to help people directly. Sometimes I will, if they're people I like, but generally speaking, I just get too many requests to for individual help to actually follow through on that. So the Slack group is the best place to get help from other developers. The only rules are basically don't be an asshole, don't be disrespectful to the people there, or to anyone really, and don't use it as an advertising platform, because it's my Slack group and I don't really use it as an advertising platform, so fair is fair. Anyways, do consider hitting the like button down below or subscribing if you learned something today. And also, this channel is partly supported by donations from wonderful people such as yourself. Shout out to my friend Victor for his recent donation. And if you're interested in learning about Kotlin and how to write the kind of code which will make your coworkers both appreciative and a little bit jealous, do consider trying out my Kotlin course on Udemy. It's basically an introduction to the fundamentals of programming in general with the Kotlin language. So just released that recently, and I'm very excited to wrap that project up. I will be adding more lessons and updating the project, or the course rather, as I go. But yeah, if you would like a sort of a polished teaching experience where I'm the person talking at you in a setting where there's more editing and scripting going on, then which isn't always good, but in the context of like a lesson, oftentimes it is. But yeah, if you'd like to learn a whole bunch about Kotlin, basically a fundamental understanding of it, which will help you get started with Android or web or wherever you want to take that language, do consider trying that course out. So anyways, that's it for my commercial. And as far as announcements, so of course the Kotlin course was released. I was hoping to release that earlier, but it just took a long time. Oh, thank you, Stanislav, for converting your name out of Cyrillic. I will actually learn Cyrillic soon. I've learned the Korean alphabet before, so I should be able to learn other alphabets. Anyways, no major announcements. What did I do for content? I released, I think, one video, which, what was it? It was Android WTF, and apologies for being a little bit disorganized. I have kind of a somewhat long lesson prepared for today's show, so I was basically working on that right up until we got started here. So what I did have one video, which was Android WTF, what is the application class, and how to set it up with Leak Canary. So Leak Canary is a tool which allows you to basically monitor your application. Sorry, just give me one moment. I didn't adjust this properly. There, that's a little bit better. Leak Canary is a tool which allows you to basically track memory leaks within your application, and you need to set up the application class in order to do that. So it's basically a video explaining those two things. And what's up, Robert? All right, greetings from the EU, from Eastern Europe. It's good day today. All right, we are going to learn about dependency and injection. So what I am going to do, what we're going to do, so I had a question sent in from my friend A, who asks, I should write that. All right, so A asks, my current app is model view view model. and it uses Dagger. I want to remove Dagger. Should I follow this space notes architecture? If so, could you explain about it? I don't know where to start. Alright, so what I thought I would do is, I actually don't know what I get asked about more, software architecture or dependency injection. Those are like the two things that everyone wants to know about. It's funny because like software architecture is a huge topic, which oftentimes can actually be explained very simply if you know what you're kind of talking about. Whereas dependency injection is actually a really small topic. It's a very, very simple concept, but the way that you actually achieve it can be quite complicated, especially if you're used to working with Dagger. So before I get into this, I just want to say I don't hate Dagger 2. What A is referring to is in my Space Notes application, I don't use any library for dependency injection. All of the dependency injection and service locator, which I'm about to show you, is handwritten with Kotlin, using a couple of Kotlin's features. Pardon me. So, does that mean I think people shouldn't use Dagger 2? If you're going to use a dependency injection framework, I do suggest you use Dagger 2. I don't suggest the other ones. I know there's Coin, I know there's Codeine. Dagger 2 has specific reasons why it's a better option, in my opinion. And I'm not saying Coin and Codeine are bad. I'm just saying I think Dagger 2 is better. The primary reason just being that it's a compile time tool, which means it generates your dependency injection implementation at compile time before you deploy the application, and it doesn't use reflection. So anyways, with that being said, let's talk about something other than just Dagger 2. So let me pull my notes together here. Okay, so I'm gonna run through a couple different points, and this is gonna be tricky. Just give me a moment here. And we got Konstantinos from Greece. What's up, man? Very multicultural today, which is great. Because like everyone knows about their own culture. I've always enjoyed talking to people from other cultures. Maybe it's my Canadian heritage or something, I don't know. Anyways, so let's get started here. So the first thing I wanted to touch on, so I'm pretty sure that my friend A understands the basics of dependency injection, but I just wanted to break it down really quickly for everyone watching. So the first thing I'd like to discuss here is just really quickly, what is dependency injection? Because it's a big, scary word, and I'm not fond of this name at all. I understand what it means, but I'm not fond of it. So very, very, very simply, what I'm going to do is I'm going to just give you a one-liner. This is my definition of dependency injection. So very simply, dependency injection is a term for giving an object its dependencies instead of the object itself building its own dependencies. So let me give you a really, really simple example. Let's just say we're working with a view model or a presenter or a controller. It really doesn't matter. And that thing needs to talk to a back-end repository. So when I say repository, you can pretty much just think database. If you don't know what repository means, that's fine. So we've got an object. We've got an object, and it uses a dependency. So the view model, I'll just say view model, but assume presenter or controller. The view model depends on the database. It uses it. That's another word for uses. By depends, we literally mean it holds that thing as a member variable. Within the view model, it talks to the room database, for example. So that room database is a dependency. So when you're not doing dependency injection, you're building that repository, that database, in the view model. That's bad. When you're not building that repository in the view model, instead you're having some other part of the application give this thing its dependency, that's good. Why is that the case? I'm not going to go into further detail because what I'm going to do, there's an article I'm going to paste in the comments, which is a longer explanation of dependency injection. So if you're still confused, I'm just going to paste this article in and check it out. And it should explain hopefully everything you need to know about dependency injection in a really simple analogy. So that was just like a back of the envelope style introduction of dependency injection. It's not complicated. This is the thing. Dependency injection as a concept is so simple, I could explain it to a 6-year-old. Where it gets difficult is actually doing it. So let's get to the next part. So for the next part, we're going to talk about what is, how do you write your own DI implementation, which is another word for the thing that Dagger 2 builds for you. Just get my face out of the way here. So this is what this is the focus of this lesson here. So how do you write your own DI implementation, which is the kind of thing that Dagger 2 builds? So what I'm going to do, I'm going to show you my approach. So this was requested by in Space Notes specifically. So this is an approach to dependency injection which I've been using for a number of months. It's not necessarily 100% ironed out, but it is working quite well for me, and I'm actually on the fence about not using Dagger 2 anymore. Like I say, the problem is that as you'll see, as the complexity of the project grows, I more and more kind of want to use Dagger 2. Anyways, I'm not going to ramble about that, but how do you write your own DI implementation? So what I'll do is I've broken this down into a series of steps, so I'll write them out and then we'll look at the code in Space Notes. So how do you write your own DI implementation for each feature? So hopefully everyone is clear on what a feature is. If you're dealing with the Facebook application, you could have home as a feature, profile as a feature, friends as a feature, messenger as a feature. So it's a distinct screen or part of an application. For each feature, how can I get rid of this monospace font here? Let's go back to Times. Okay, something like that. All right, so for each feature, create, oh, that looks even uglier, but whatever. Let's get, sorry, I'm having a OCD moment. Do I have Roboto installed here? There we go. Let's do Roboto. That's material design, isn't it? Okay. So for each feature, create an injector class which contains the what I will call build logic, because that's actually what dependency injection is all about. It's all about separation of concerns with build logic. If you want an easier way of thinking about dependency injection, you're literally just pulling build logic, the commands necessary to build something, out into a different class. So create an injector class which contains the build logic for that feature. Build, yeah, I just explained that, but build logic is what you need to have that feature work. So creating things and wiring them together is basically what build logic is. So let's hop into the simplest example of that in Space Notes. Okay, so let's go to, what are we doing here? So step number 1, create an injector class. So if I have a look at this package explorer here, so we're in the app package of Space Notes. So for each feature of this application, so we've got login feature, note detail feature, note list feature. Each of these is going to have a sub-package called build logic. You don't necessarily have to do it this way. I'm just going to show you how I do it. So we're going to be focusing in for this lesson on the simplest feature, which is the login feature. And as I said before, step number 1 is to create a injector class. So what does that look like? So the purpose of the injector class is it's going to basically create the backend things that you'll need, the dependencies you'll need. It's going to create, say, the presenter or the view model, well, actually, we'll get into that in a minute, because if you're using view model, the process is different. But it's basically, like I say, the purpose of this injector here is to create dependencies, and when necessary, give those dependencies to particular different objects. A couple of hints right off the bat. Generally speaking, in dependency injection, when you're creating things, you're going to need a hook to the application context of your application, your Android application. So I've actually made this dependency injector an Android view model class. This is just a tip, you don't have to do this. And the purpose of Android view model is that it's a special view model designed to hold application classes safely. So that's why I use that there. Now that does change things a little bit, because that means I have to build this injector using something I'll show in a minute. But anyways, this is what a simple injector class looks like. So what you'll need to put in here really depends on how you structure your application, but hopefully the general idea makes sense. So that's kind of step number one. Also, pro tip, I don't actually need to use this here. Technically, it might on occasion help, but in Kotlin we have this thing called a lazy delegate. And what this thing does is, by using lazy, I don't load this resource until I need it. This feature basically always needs to have this auth repository, so this isn't actually helping too much in this feature. But if I really quickly hop into Note list injector, we have like a lot of backend services here. As you can see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 basically, although some of these are just nested within each other. In this case, this is where lazy comes in real handy, because if the user's not registered, I don't want to load the registered backend for them. I really don't. That's a complete waste of memory. So that's just another little tip, is to use lazy for these things. Don't necessarily have to do it everywhere. Okay, so you write your injector class, and this is where, if you're using Firebase, you would create your application here. If you're using Room, you would call your database, your Room database.getInstance, to get access to a data access object. So that's kind of what we're looking at there. All right, so that's step number one, write an injector class. Now the second step is, just let me find my place in my notes here. So the next step is we need to, of course, get this injector class. So I'm going to open up login activity. And in login activity, so just a really brief point, there's a note up here. Why did I decide to use an activity as a view in this feature? The reason I did that, and the reason why I'm breaking separation of concerns here, is that in this feature I am tightly coupled to onActivityResult. So if you're wondering, no, it's not that Ryan suddenly had a change of heart and now he's using activities as views everywhere. I only do that in this feature because of the tight coupling to onActivityResult, and because the feature just has one single button. So I'm not worried about pulling everything out into the view, the fragment view, the application container. It's a pragmatic decision. But the good thing about that is it's going to show you a simpler way to do this. So in this case, in the activity class, and this will occur even in the features where I do use the fragment, I'll still use, I believe, this, or maybe I have it in the injector, never mind. You'll see in a minute. Okay, so when I want to get a hold of this injector class, because it extends Android view model here, I need to get a hold of it using viewModelProviders.of. And what I've done is I get the class, and then immediately after I get my login injector class, I call .build login logic. And this is the really critical part. I pass in the view. So what happens there? So we go into this function here, build login logic, and the view in this case is an activity. Sometimes it's a fragment. And what I do is I basically create my view model, you could say, or my logic class or my presenter or whatever with the view. So if you've ever worked with Dagger 2, you should be familiar about passing views into your dependency injection setup. Another thing I do, and this might be a little confusing, but this is just, so instead of actually directly talking to the logic class or the view model or the presenter, I actually use this event. Basically, this is like an observer. This is an observer pattern implementation here. So what happens is I create the logic class, and then I call view.setObserver, and I give it the logic class. Let me open up that logic class, login logic. Login logic extends observer for login events. So basically it's saying I watch user interface events. The login activity, how it actually publishes events, is it just changes the state of this live data object. So this is not me putting shared mutable state in the view as a means of saving user data. This is just a communication channel. So don't be confused and don't assume again that I'm trying to save the state of the application in a view. That's not what this is. By doing this, instead of directly, basically this is to replace having to directly say to the view model, instead of saying like view model dot login event on backclick, it's basically an implementation of the observer pattern to remove the dependency from this login activity. Okay, so we register our observer, and then after that happens here, and then once our view hits on resume, or whatever this might change for your app, then it publishes that event to the logic class. And notice it doesn't do that directly. It just changes this mutable live data up here. And the mutable live data, all it possesses is, let me just show you really quickly, login contract. It's just a sealed class, just like so. So that's all that's going on there. And this is just a really handy way. Once that happens, whenever basically this event thing gets called, whenever we say event.value equals login event.start, then that event gets passed up into the logic class, and then we just deal with it from there. So anyways, that's a little bit beside the point, but that's the basic setup for the dependency injection in the front end. So one, create your injector class, use view model.providers, or no, what is it, view model providers dot of something dot get type deal. If you're using view models, which you clearly are, and then wire everything up based on lifecycle events. So this could change quite a bit based on how you actually set up your application, but that's the basic general process here. So the last part of this lesson, and before I get to that, I'm just going to run a quick commercial break. So do me a favor and hit the like button down below if you have learned something so far. All right. And if you have an ad blocker, you can wait with everyone else. Okay, and there we go. Okay, so this basically takes care of the front end of your application, but the problem is, okay, so what about the back end of the application? So how do we still decouple our back-end services now that we don't have Dagger 2? So what we used to do with Dagger 2 is we would inject those dependencies into the back end using our whole big complicated setup, which does work if you know what you're doing. I'm not criticizing that, but how do we do this without Dagger 2? So this was a problem that I wondered about for a little while, and I was actually inspired by functional programming. Excuse me. And I thought, well, why don't I try to treat my backend and my domain layer as pure functions? So you don't need to understand what I just said to do this. Don't worry, it's actually really simple. But if anyone's kind of wondering, this is where I got the inspiration to use this particular pattern. So in Space Notes, I use a service, you could say the service locator pattern, at least my interpretation of it. I use the service locator pattern. So how does this thing work? So when we want to actually get to the back end, how do we deal with that? How do we set up our room database or something like that? Okay, so how this basically works is in our Injector class, we create the backend service that we need. So in this case, we have in this feature Firebase, but this could be a room database. In this application, I have features that have both Firebase and room. So what we do is we create this in the Injector class, and then in your, for example, view model, or in my case, the logic class, I give it a service locator object. In this case, all it needs is just an auth object, which is part of Firebase. So what does that actually do? And how do I use that? So when I want to call, for example, when I want to get the data from the backend, get the most recent user, what I do is basically, so in this case, we do have our middle domain layer. You could pass these dependencies into a repository instead. So basically what I do is when I want to, for example, what's a good example here? Let's take when I want to sign the user out. That's a simple example. So what I do is I take this service locator object. Let me show you what it looks like. So user service locator. It's pretty simple. It's literally just an empty class with one property. And notice how so two key points here. If you're doing, this only applies if you're doing like multi-module projects, but I actually define this service locator in my domain layer. So we have a user service locator for Firebase auth, and then a note service locator for room database and Firebase, or Firestore rather. And it holds whatever it needs. This is a more complicated one, so it's like 4 lines long. And notice how it's full of interfaces. This is actually how, just a quick tip here for advanced users, this is actually how I keep my domain layer free of these backend libraries, but I can still use them. So that's the power of abstraction right there. Anyways, I tangented a little. So when we want to, for example, sign a user out, so we have this auth source object, which is part of the domain layer. Don't worry about that too much, but just let's see what it does. So it gets given the service locator, and then from the service locator, I say locator.auth repository, which again, we're actually talking to this thing here, this Firebase auth. I say service locator dot, it was sign out current user was the one that I used here. So what ends up happening, so the actual auth repository exists in the backend, the data layer or data module. And in Note, and this will be for everyone, I think. No, not Note, it's in auth. So this is where this thing actually exists in the data layer. And yeah, that's basically it. So it has the auth object, it actually does whatever it needs to do, and that's basically what's going on there. Okay, So as you can see, the purpose of this service locator is you pass it into the repository or the use case, and from that thing you get a hold of the sorry, I just got a YouTube comment pop up. If you pass that thing into the repository of the use case, and that's how you get a hold of your backend, and you're still applying dependency injection in the repository or the domain layer. So I've actually gone even a step further, and this is what I'm going to probably convert the thing I just showed you to in the, let me just show you really quickly, in the for public users, I've gone a step further, which is that the actual implementation of the backend is an object, so it doesn't hold its own state. It doesn't do what I showed you in that repository. I'm not sure where it went here. Yeah, it doesn't. Let me just pull the class I just had. That was the Firebase auth repository. So it doesn't hold on to an object. It actually basically gets everything passed in within the scope of the function itself, and it's a singleton because it's an object. So this is actually what I'm moving towards, everything in the back end hopefully being objects which get given what they need, which is a form of dependency injection. So anyways, the key point here is that in order to actually give things to the back end, we are still applying dependency injection, except we're using it by combining a functional programming approach, which is to pass everything in that a function needs in the brackets. So this is dependency injection right here, with the service locator pattern to actually hold on to those backend services. So that's the basic gist of it. Let me just double check my notes to see if I glossed over anything. I was going to take everyone through a complex scenario with the note list feature. I'm not going to do the end-to-end thing because we're already like 30 minutes in here. But let me just show you. So here's the thing. When you're writing a simple application, I would suggest doing this kind of thing instead of using Dagger 2. But here's the problem. Here's where Dagger 2 starts to shine. If you're building a pretty complicated application, then this code ends up starting to look like this. So we have a lot of stuff going on here. So this is the kind of thing where it can actually be handier to have Dagger 2 implemented for you. Now, I'm not finalized on this approach. I think there's ways I can actually really optimize this. So for example, if I also open up Note Detail Injector, you're going to see a lot of repetition here because these things work on the same dependencies. So currently they're separate and self-contained, which is kind of nice, but the cost of that is that we're repeating the code. So I could probably abstract some of this out, and in fact I could probably use like one injector class for both the note list feature and the note detail feature, and then I could just have two separate build functions. I'm not sure, because the problem with that is then we're not necessarily separating things, but we'll see. I'm still playing with it. But anyways, to wrap this up, that's my basic approach to dependency injection in Space Notes, which doesn't use Dagger. So we have front-end injector classes which extend, you don't have to do it, but they extend Android View Model, just because that's what Android View Model is specifically designed for. And then we use the service locator pattern to actually get the backend dependencies into the backend and keep everything working properly. So that's it for my lesson on dependency injection, custom setups, and let's check out the chat for some Q&A. Oh, I'm out of breath. Okay, just give me 1 minute. Okay, what questions do we have? Okay. That's a good question. All right, so from Konstantinos, the question is, oh, no, that's the wrong one, sorry. I copy-pasted the wrong thing. So Konstantinos asks, why is it so complicated to test an object that is related to Android, for example, room library? So there's a very clear answer here. I can give a very concrete answer. So in general, we want our tests to be written and executed as quickly as possible. So you'll notice, let me pull up a specific example here. So let's look at login. Now we'll look at, we'll do login logic, I guess. I might change my mind as I do this. Oops, I want the test actually. Okay, so so this is the thing I talk about a lot, like why do I go through so much trouble to have a logic class which doesn't have dependencies to any Android frameworks? I do stretch the rules a little bit because it extends lifecycle observer, but I only do that because it's just a little bit easier than having all these different lifecycle callbacks. And I would only use this in a front end in the Android. But this doesn't actually change the fact that I can still run my login logic class on the JVM. And so this is the key. Classes which don't have dependencies / tight coupling to the Android framework can generally be tested on the JVM. When we run JUnit JVM tests, we don't require the Android OS nor a device to verify our code. So this is the key point here, Konstantinos. So when we're running JVM tests, we're actually just running them on a JVM. We don't have to use them with a device. So basically what I'm getting at here is the purpose of me basically trying to pull all of the logic of the front end of a front end feature into this logic class, which is very much like a presenter. And this is the main point of Model View Presenter as well, if you're curious, is that it allows me to test the logic of the application on the Java virtual machine. So I don't need to deploy it to an application. I just need to hit the play button and it runs the thing on the JUnit test. So it's faster, it's easier to write. So this is, to answer your question, this is, what was the original question? Why is it so complicated? If you can run the test on just the JVM, then with JUnit, it's quick and easy. If you have Android libraries, like for example, a room, you actually can't test a real room database on the JVM. There's things you can do. There's tools like RoboElectric, and there's ways you can kind of still test Android framework classes in a test environment. But I don't really tend to mess with those things because they require a lot of configuration, and my solution is actually just to pull all the logic out of the view, out of the view model, pull the logic out of that, so I don't even need to bother with those other tools. So I'm not saying you shouldn't, but that's just not my particular approach. So anyways, to really, that's the answer to the question, is that dependencies to Android often require you even having to, for example, test your application on a device, whereas if we're just testing things in JUnit, I don't need to deploy this. I don't need to like build the whole friggin'... You do have to kind of compile your project, but I don't need to deploy it, and it's a lot quicker. So that's basically the answer there. I don't totally understand your follow-up question here. I know that you have to mock the object, but why? Oh, so why do we use mocks? So, okay, let's I'll jump to that one next. That's another good testing question. So as a follow-up, why do we use mocks? So I'm kind of rephrasing your question a bit, but hopefully you don't mind. So really simply, the reason why we use mocks is because I've applied dependency injection here, because I give this logic class, which again you could think of as a presenter or a controller or a view model, whatever. Because I give it its dependencies, the purpose of the mocks is to give it fake dependencies, because I can actually test the behavior of this class here, this logic class, without real dependencies. Again, which means I tested on the JVM. If I gave this thing a real room database, I could not run it on the JVM. You can't. I think in RoboElectric you can like mock the entire Android framework and then you could maybe kind of do it. But again, that's a solution by literally mocking the whole Android framework. So anyways, that's actually just, simply put, that's why we use mocks. So what do they do really quickly? They allow me to create the thing I want to test. So here I'm creating this login logic class with the mocks, the fake copies. And then I can tell these fake copies exactly what I want them to respond with. Whereas I can't do that if I'm using the real room database. So now let's say I want to know what happens. How does this logic class behave when the auth database returns a user? How does it behave when the auth database returns null for a user? And then I verify, okay, well, let's make sure that the logic class is calling these particular functions on the view. So I'm basically seeing how this logic class deals with its various dependencies and responds to the events. So I can verify that this thing is behaving exactly the way I want it to without talking to the real fragment, the real view, without talking to the real database. So that's why I use mocks. All right, I'm just going to run another quick commercial break and then we'll get back to more questions. But excellent questions today. Thank you. Oh. Okay, and we're back. Looks like Stanislav gave some good feedback as well on why you should use mocks and try to avoid testing things which are tightly coupled to the Android framework. Umberto asks, hey friend, you never take a break? The way I kind of look at it, man, is I can work my ass off when I'm young, or I can be like a lot of people I grew up around who are working their ass off when they're old, and I would prefer to do it when I'm young. But I don't take many breaks. I'm not proud of that, but that's just the situation I am in right now in life. Okay, I'm not gonna, I get asked this too much. I'll give a quick kind of input on this. So So AJ mentions you seem to be using MVP. So just a quick correction, AJ. I don't actually use Model View Presenter anymore. I don't use that name. You'll still see it in, like, for example, my Kotlin MVP calculator app, but I actually don't use the term presenter. I use the term logic class. So let me pull up. Okay, I guess I am going to answer your question in detail. I'll try to go through it quickly. I just need to pull up a graphic in order to explain this. So I don't... my advice to everyone watching this is just completely drop the idea of Model View View Model versus Model View Presenter versus Model View Controller. Which one is better? That's the wrong question to ask for several reasons. Number one, people don't do Model View Presenter or Model View View Model consistently. Everyone has a different way of doing it, more or less. Not entirely, but especially with Model View View Model, there's a lot of ways to really screw it up in terms of separation of concerns, which is the whole point of Model View View Model or Model View Presenter, to make your architecture modular and easy to test. So what do I do now? I'll show you in Space Notes. Okay. I'm going to blow your mind, AJ. Okay, so in the login feature of Space Notes, I have my logic class. I have the activity, which in this case functions as a view, but normally I use fragments. As I said earlier in the show, there's a very specific reason why this view is an activity, and it's not by ideal choice. So I just have a view, a logic class, and that's it. So most people looking at this, they'd be like, well, this is basically Model View Presenter, except when I open up Note Detail, notice how there's a logic class, there is a view, and there's also a view model. Oh, well, what is this? Is this Model View Presenter? Is it Model View View Model? There's a view model there. And then when I open up Note List, we've even got an adapter going here. So, and then we've got the view model and the view. So what's going on here? Like, why am I not doing exactly the same thing in every feature? That's because the actual architecture that is ideal for what you're building depends on what you're building. So do not be under the lie that Model View View Model or Model View Presenter, either of those are the best architecture. Neither of them are. There's no architecture style which works perfectly in every situation. Model View View Model works well in some situations, and depending on what your priorities for testing are, Model View Presenter works well in other situations. So I'll use whatever components I want to use based on what I think I need in a feature. So to answer your question, I don't actually use Model View Presenter strictly anymore. I'll use a view model when I think it's appropriate. I definitely don't do strict Model View View Model because I'm gonna give it away. There's actually no single consistent way to do Model View View Model. The only distinguishing characteristic with that particular pattern is that you're not allowed to have the view model talk directly to a view. That's the whole point of it. And in some cases that's really useful. In many cases I actually like to talk directly to the view. So anyways, do Model View View Model if you like it and it makes sense to you. Don't be afraid to have a logic class, what some people would call a view controller. And the reason for that is very often you have logical decisions which need to be made in the front end, and a lot of people will just stick those that logic in a view model, or they might do it properly by just exposing the data, that's fine. But if you have like extensive logic in your view model, which I don't, do consider pulling it out into a logic class and then have that thing talk to the view model. This is the wrong class I'm pointing to here. Let me show you Note list logic. So in this case, the note list logic, I have this thing because now we have all of this, you see all the logic going on here. I don't want to stick all of that inside a view model. That's a horrible idea, in my opinion. However, if I don't have a lot of logic, I probably should just have a view model. That's where model view model really shines, is when you don't have lots of complicated interactions with the views. So anyways, I went all over the place here, but basically to answer your question, AJ, there's no such thing as the perfect architecture, and you're going to read a lot of articles by people saying A is superior to B, and you actually can't say one is superior to the other. You literally can't, because it depends on what you're building. So that's my answer. I do not have problem with your name, Stanislaw. It depends, like maybe Stanislaw is say I don't pronounce name correctly. Well, my grandfather is Polish man with name Stanislaw Tadeusz Radlinski, so I don't know how to say Stanislaw. It depends on where you're coming from. Anyways, okay, so hopefully that answered AJ's question there. Sorry, that was a bit of a random rambling. Okay, a lot of questions today, which is good. I'm not complaining, but I am running out of breath. Okay, so that was AJ's question. So Stanislaw, I won't give a long answer here, but Stanislaw mentions, have you ever had an idea that if we mock all the stuff, it sometimes becomes so synthetic? How can we be sure it works in general? It really, to me, it depends on how you go about doing it. So my goal with the object which has mocks is to basically pull all of the logic in, say, a front end into one object of a particular feature. I'm not saying like have one single object in the whole application which has all the logic. I'm not saying that. And then I try to keep the view model, the view, the adapter, everything else as humble objects, as I think Uncle Bob refers to them. So humble objects are things which are, there's different opinions here, but I would argue you can test them just by kind of looking at them. So what I would say is if you've pulled all the, if you've created like some big presenter or logic class and it has all these different mocks, you can only verify the behavior of this particular object. You're still not verifying whether the view model or the view works. So the way I deal with that is the whole purpose of the logic class is to make sure that I don't have anything really complicated in my view model or my view. I can basically just look at them and eyeball it and tell whether or not they work for the most part, which isn't necessarily an ideal. Some people like 100% code coverage. So what I would say is if you still have a lot of logic in those objects that you're mocking, you are not really getting adequate code coverage, and there's almost no point in having this logic class. You kind of, if you actually want to verify that your thing works, you need to test all of those classes if they have logic in them. That is an interesting point, but that's all I can really say on there. Hey, what's up, Marseille? Okay. May I ask, where are you from? I'm unfortunately probably going to mispronounce your name, but I'm just totally curious. Is it Jabez or Jabez? And I'm just curious where you're from, because I generally can recognize where people are from based on what name they have, or what their ethnicity might be, but I'm not familiar with your name, so I'm just curious. Anyways, Jabez, until this individual corrects my pronunciation, asks, when unit testing a database, is it a must that you mock it because you can still use an in-memory builder that creates and destroys the database after the test? So is it a must that you mock it? Absolutely not. So here's the thing, like, what are you actually testing, Jabez? Like, if you're writing a test for a database, like, you're actually kind of trying to test the implementation of the database, which actually the developers of the database should have verified that it works themselves. So the thing that talks to the database, oftentimes you'll want to mock it if you want to execute the test quickly, say on the Java virtual machine. But you can certainly use an in-memory database. You can do that. Unfortunately, so Jabez, I can't answer your question again, but please do go back and watch the recorded version of this video, because I literally just explained what mock objects are and why we prefer using unit testing when possible and using mocks. I literally just explained that in detail, so you'll have to go back and watch the recorded version, which will be on the channel, of course. But yeah, hopefully I answered at least part of your question here. All right. Oh, you're from Kenya. Okay, awesome. And hopefully Jabez is a decent pronunciation. Awesome. Good to hear, man. Okay, so I'm only going to do like maybe 2 more questions. All right. So, oops, what am I doing here? Sorry, give me a moment to collect my brain. Usually after about the 45-minute mark, my brain actually starts to slow down a little, so I do apologize. Okay, so this is from Konstantinos again. From Greece. All right. So, can you give me a simple example where the repository pattern should be used? Absolutely. In fact, I'll do it on the whiteboard because I can. Just give me about 5 minutes to draw something out. Apologies for the dead air. For those who have just joined me, I'm just drawing out an example so that I can answer a question. Okay. So, for anyone curious, I'm going to explain to you literally the ultimate purpose of the repository pattern, and it's actually pretty simple. Okay, let's say we're building, oops. Oh, that's supposed to be an arrow, but it almost looks like something phallic. Anyways, okay, so when should we use the repository pattern? So let's say we have an application and it needs to talk to a local service and a remote service. So let's say, for example, we have a local room database and we have a remote Firebase Firestore database. They both act on the same data. So when we're not using the repository pattern, we have a situation where our logic class, or if you, I almost said something I would regret. If you don't like to build apps like I do, this might actually just be your activity, which I don't suggest. But whatever class needs to talk to your back end, and this is the key for the repository pattern, this is where it shines. Whichever class needs to talk to your back end, in the event that we have these two services that act on the same data, and I'll show you an actual code example of this, what we do, okay, so when we're not using the repository pattern, we directly talk to A and B, services A and B. We directly have the logic class send a message to, say, the remote, and if the remote says, yeah, no connection or fails, then that response goes back to the logic class, and then the logic class has to ask the local database or whatever, room database, for the data instead. So we have our logic class and it depends on two different backend components which work on the same data. That's stupid. Instead what we do is we use the repository pattern. So instead of having the logic class know what A and B are, it just has a repository. So this is an interface. So it's an interface, so logic doesn't even know what's behind here. It has no idea. It doesn't know what dependencies this thing has. Okay? So what is the perfect example? So what we do is we create this repository, and the logic of responding to what the remote and the local say, we put that logic in whatever object implements the interface in the back end. Why? Because the front end logic should not care that we're talking to these two databases. In fact, and this is the key point, watch this. Let's say, for example, something magical happens and the requirement for our application is that we need 4 data sources. Our project manager comes up to us and says, you need to not just talk to a local and a remote from, say, Room and Firebase. You need to talk to as well, let's just say, give me a moment. You need to talk to as well an Amazon Realm, so a Realm local database and an Amazon remote web service, Amazon Web Services database. That's our new requirement. Don't ask why, just let's say we have to. Okay, so if our project manager gave us that new requirement and we didn't have our repository, I would have to draw lines now, dependencies to all of these different things. And the logic class would need, which is a front end class, it manages the front end, so we're thinking a presenter review model. I would need to add all these dependencies which all talk to which all have the same data. They all just retrieve a note, say, in this logic class. If I use the repository pattern, this should blow your mind if you're a developer here and you don't know about this. When you have a repository pattern, I just almost destroyed my phone. No matter what you add to the back end, even if we have to have 4 services back here, I don't have to change the logic class at all. It still only has one dependency, which is the repository interface. So the purpose of the repository pattern, and this is very common when you're talking across architectural boundaries. So we're going from like the front end of the app if you imagine that this is the front end of the app, so model view presenter up here, well, view presenter, and then this thing is the back end of the application. This is a back end detail. I should not have to change the front end based on what happens in the back end and vice versa. So that's why we use the repository pattern. And this is why interfaces are actually like one of the best things ever. So hopefully that answers your question. So yeah, that's why we do the repository pattern. That's literally the best use cases when you have a local and remote database. That's exactly when you want to be using the repository pattern. Okay, let me just rearrange things here. So I'll only stick around for a moment longer. All right, so Marcin asks, what is the right way to understand my Space Notes project? So here's the thing, it's pretty complicated. I'm trying to think of how to parse your question. To be honest, so here's the thing, Marcin. I'm actually possibly as early as today, although maybe not, I'm going to write out a README for that project, and it will break down the whole architecture. So I'll help you out in that regard soon. That was something I'm planning. Architecturally speaking, this is the architecture for that app. It's whatever I need for the front end, which sometimes I need a front end data store, which is what I use a view model before. Every front end has a decision maker, which I just call a logic class, and every front end has a view, which obviously renders the user interface. And then in the back end, I'll have a back end decision maker, which is often a repository or an interactor, like a use case thing. Don't worry about the jargon. And then we have the back end data sources, so databases, network, and stuff like that. So this literally is the front end architecture and back end architecture, the whole architecture for the application at like a view from, if you were to look at it from 100 feet in the air, that's kind of what it would look like. Beyond that, what I would suggest, so I'll put a README together soon. I also have an article on separation of concerns here. One sec. I do talk a little bit about Space Notes architecture in this article. So I basically go through in one of the more complicated examples and explain what each component in the feature is, so what each component does and how it kind of relates to three-layer architecture. So what I'll do is I'll paste that in the comments here. And so beyond that, Marcin, what I used to do, I know exactly what you're going through. So what I did when I came across a repository which was like more advanced than what I was used to, or in a different language, I basically literally went through every class and attempted to explain. I cloned the repository and I went through every class, or at least of a particular feature, and attempted to explain what each thing does so I understood what it does. So that's an approach you can use is to go like class by class and build like on paper or something like that, kind of a model of how the application works, and that can also help a lot. I did that with this Android 10 GitHub repository, which was like a super advanced clean architecture thing a couple years ago, and I learned so much from doing that. So it's difficult. It'll take several days probably, but that's another approach you can take. Stanislav, these are mutable live data objects. It's okay to have them as vars. I don't agree with you there. It's okay to be talkative though. Talkative is good. But yeah, these don't need to be vals. Why would they need to be vals? Like, we're literally, these things get changed all of the time. So this would be the specific case where you would want to use a var. Like, I understand you can make this a val and then that will make this reference read only, but like, I'm not actually losing anything by having this as a var here. They're private. So anyways. Okay. Okay, one more. Holy crap, so many questions, which is good. Okay, two rapid fire questions, and then I'll call it a day. So I'll try and answer this quickly. So Jabez asks, how do you think the Android developer landscape will be this year? And what should we focus on? What are the new patterns? So there's a few things that I liked in the I/O 2018. So I do like some of the architecture components. Okay, so I do like some of the AAC stuff. So number one, by no means, I don't like all of them. I like view model, live data, and observer from lifecycle in my front end. I don't like using the AAC backend libraries except Room. So there's like, for example, paging. There's a couple libraries I don't like. So I don't like the paging library. I'm not super sold on the navigation library. It's not bad. I don't like the paging library because it tightly couples my backend to an Android front-end library, essentially. Well, it's not really a front-end library. The problem with paging is that it basically takes over your architecture and tightly couples it to Android from what I saw, and I don't do that. I'll have Android classes in my front-end Android module or my back-end Android module. I won't have them in my domain module because I'm actually going to be doing multi-platform projects. So Space Notes is going to have a web front-end written in Kotlin JS. So anyways, I'm tangenting. Let me get back to this thing. So yeah, check out AAC and don't be afraid to use view model, live data, and things like that in the front end, because they work really well with the Android front end. It's easier than having to like manually check the life cycle kind of stuff. I really do like it. I like Room. Some of the other new stuff I'm not too big on. I'm not saying it's bad. There's specific reasons why I don't like some of them. I really strongly encourage Kotlin, and it's not just because I recently released a course in Kotlin, but for real though, it's not that I want you to like buy my course and that's the only reason why I encourage Kotlin. Every developer I've spoken to who has converted to Kotlin for Android for a significant period of time understands that it's better than Java. And when I say better, what I mean by that is it has more features. The syntax is about 40% better, like in terms of writing 40% less lines of code to achieve the same effect. And then a big thing is coroutines, which you can actually use to replace RxJava and a lot of other things. So in this year, I strongly encourage people, if you haven't already, listen, Android has a lifespan, I do believe, and I would guess it's probably within about 5 to 10 years. We're moving more towards Kotlin. I think there will be Java applications until Android itself basically dies, but Kotlin's getting bigger, and there's a lot of support for it for Android, and I do think you should make that transition if you haven't already. You will eventually like Kotlin if you try it, because it really is, it feels like what Java should be, and then some. Any other points? Okay, this is a big one. In my opinion, I'm moving towards developing, basically, why is my brain not giving me the word I'm trying to say here? I know what this word is. Come on, brain. This is what happens when I'm tired. Multi-platform. That was the word. I know the word. I'm building multi-platform applications, so consider looking into multi-platform. So you could do that through React, like a JavaScript thing. Oh, sorry, my face is blocking what I'm typing. I'm actually going to be doing multi-platform, so that'll be, for starters, just Android plus web using Kotlin JVM and Kotlin/JS for web front end. JS. Obviously, I really like Kotlin. You could use JavaScript. I don't like writing in JavaScript. I just don't. And then you can even use, a friend of mine, Derel, is working on doing, adding as well to the mix, iOS with, I believe he's using Kotlin native, or at the very least he's writing an iOS front end and it's talking to a Kotlin server. I'll have to ask him to confirm that 100%. So what I'm saying here is consider looking into multi-platform, because here's the thing, programmers and subscriptors, there will come a point, so as much as it pains me to admit this as primarily a mobile developer, there will come a point where we don't have these things anymore, because just it's okay. There will come a point when we don't have these things anymore, because this is a stupid, clumsy, like, what's a better interface tool, a keyboard or using like 2 thumbs? So these things in 5 to 10 years, I'm quite certain will, if not disappear entirely, drastically change. So, because we're going to be able to just interface with machines a lot quicker within, I would say, optimistically 5 years, more conservatively like 10 years. So what I'm saying here is I don't suggest hardcore getting into Android native or iOS native at this point and focusing on that. I think everyone should kind of start heading towards browser-based front-end tools like, I'm not necessarily saying you should learn React, but things like that. There is also, of course, Fuchsia and Dart, and that's another basically attempt to supplant Android, which I'm not on the fuchsia hype train yet. There's a big hype train and they're really trying to push it. I'm not there yet. I'm going the JavaScript route with Kotlin, but that would be kind of my suggestion there for that question. And then there's one more. Oh, that's not the one I wanted. So Stanislaw asks, so I don't have special IT education. No, I have zero. I have 1 semester, 3 classes of post-secondary education, and then I had to drop out. I decided to drop out, A, because I couldn't afford to continue, and B, because I was learning less than I was learning on my own. So I thought, okay, I'm not going to put myself in like 20 to 60 grand in debt just to get a bad education. And so I'm basically almost entirely self-taught. I have 1 programming course in post-secondary. That's it. The other class was technical writing and then legal institutions. So yeah, I am as academically unqualified as it gets. So if I don't have a special IT education, do I struggle from that algorithm knowledge leak? I'm not 100% sure what you mean. I think you're talking about lower level computing knowledge. I don't struggle with that so much anymore because I'm actually learning low level programming on my own time. So I would say about a year ago, or even as little as 6 months ago, I really didn't have knowledge of, for example, C or digital circuits and voltage transfer characteristics and metal oxide semiconductor field effect transistors known as MOSFETs or CMOS. I can't even remember what that one is. So I am having to deliberately learn that myself, but I'm actually having a better time teaching myself than I would have in school and saving money doing that. So that's kind of the thing. Yeah, certainly that was a big hole. If I'm understanding your question correctly, that was a big hole in my experience. I was really good at building apps, but I didn't really know how computers worked in that regard. And I'm having to make special effort to do that. Oh, I clicked on the wrong thing here. So anyways, hopefully that kind of answers your question. As far as knowledge leak, I don't really get that because I do get it, but I study basically every day. So, yeah. Thank you very much, D. Phoenix, for the kind message. That's a great analogy. So Stanislaw has an analogy in regards to Kotlin versus Java. So Kotlin for Java developers is like to take off shoes, which are 2 sizes less than your actual foot size, as such a release. That's a very good analogy. As someone with exceptionally wide feet, I know exactly what you're talking about. Okay. Looks like that's it for questions. I might have missed 1 or 2, but hopefully that was cool for everyone. Thank you so much for the wonderful questions today. I had a lot of fun, and yeah, hopefully I was relatively insightful on a few things, and I'll hopefully see everybody soon. So I know I said I was going to start doing it sooner, but I am going to start rebuilding some projects live very shortly. And I'm also going to be doing some more dedicated intermediate level Android tutorials in my own style. And so there's going to be more content coming soon. But yeah, it took me about 6 weeks to wrap up the Kotlin course that I put together. And I just finished it up like a couple days ago or a week ago. So now that I'm done that one, then I'll have more time for other things. So do consider checking that course out if you'd like to learn Kotlin and learn a whole bunch of other stuff, because I even talk about the repository pattern and all kinds of software architecture knowledge in that course. So it's an introduction to programming in general. I even get into a little bit of computer science. But yeah, that's it. Thank you so much for watching, everyone. I hope you all have a good morning or evening or middle of the night or afternoon or whatever it is for you. It's late morning for me. Thank you so much for watching, and peace out.